And the major gaseous pollutants are sulfur oxides and nitrous oxides. So as they're gases, you can't use a cyclone or a bag filter or an electrostatic precipitator. So what can we do? For sulfur oxides, well, for a start, they come from burning fuels which have a high sulfur content. So the obvious thing to do is to use low sulfur fuel. And as you're aware, there's a move from coal, which can be quite high in sulfur content, a move from coal to natural gas, and that is generally a lower sulfur content. There is a technique called desulfurization. Or you can try and remove the problem by using tall chimney stacks in the hope that you reduce your ground level concentration in the immediate vicinity. But then, as I mentioned in an earlier video, the problem may show up even in a different country with the prevailing west to easterly winds. Quite likely the smoke emitted in Great Britain is going to fall as acid rain in France and Germany. And there is a technique for flue gas desulfurization. So that's sulfur dioxide. And the other one is the nitrogen oxides, nitrogen dioxide, nitrogen trioxide, generally referred to as NOx. You can use these things called wet scrubbers, which are essentially sprays. You draw your air through a spray chamber, and that drops out the oxides of nitrogen through as nitrous and nitric acid. And you can also adjust the airflow in burners so that you limit the amount of NOx produced. There's another series of compounds called VOC, volatile organic compounds. And then there's this question of control of carbon dioxide. But wet scrubbing doesn't work particularly well with CO2. And the current approach is, as we mentioned earlier, is to reduce CO2 emissions by alternatives for electrical generation and also vehicle propulsion. So now we come to this interesting question of how chimneys work. And the whole idea is to put the gas up as far above the ground as the pollutant as far above the ground as possible, and then hope that it goes away. But that may or may not happen. And I've given you a series of pictures here to explain what can happen with a plume from a chimney stack under different local atmospheric conditions. So you can have fanning, you can have fumigation, where there's a substantial spread of the plume. The plume can stay pretty concentrated, it can loop up and down and loop and touch the ground, which is pretty nasty. Or you can have coning, which is the ideal dispersion. And you can have this combination of the two or combination of, where are we? Of fanning and coning, resulting in lofting, as illustrated there. So the last thing I want to look at is the control of moving sources. Now, clearly, one of the solutions is to have electric vehicles, but in a sense that just moves the problem elsewhere. However, it's a lot easier to control pollutant emission from a stationary source such as a chimney than it is a moving source such as a truck or a vehicle. So all you can really do is make sure that your engine is working properly. You don't get unburnt hydrocarbons, and you can use catalytic reactors or converters, as most modern cars have now, as well as doing tune-ups, exhaust gas recirculation. So that's the end of this little talk. And I just want to leave you with the thought that the basic principle of most environmental control, and this applies to noise as well, is that if you can prevent it, that's usually the cheapest and most direct way of doing it. You can isolate it, which can sometimes cause other difficulties, or you can control by changing the time of days of admission or the places or other mitigating devices. So that's the end of this one. And we've got another one to come. And that'll be the end of this particular work for the week. So thank you for your attention.